Hi there, in this recording I'm going to be showing you how to use NC's function for working with data tables as input subjects. So in the last tutorial we saw that we created this curpos dt, which is a data table which we may want to match the pause column using a regex. And we did that in the last tutorial using this capture all stir function. And so the other kind of basic capturing function that NC provides is called capture first, capture first df. And so this is specifically for the case of a data table or data frame with a column that you want to match. And so here what we do is we're going to specify that data table as the input as a first argument. And then all of the other arguments are going to be interpreted similarly to the other functions, but with the difference here that the names are going to have to denote the columns of the subject that we want to match, and the values are going to be the patterns that we want to use to match. So here, for example, we're going to use pause equals range pattern because pause is this column name with these chromosome genomic range strings that we want to match. And range pattern, well, this is this pattern that we've defined in previous tutorials using list subpattern variables, and that is going to be able to match this regex. So what we mean when we write pause equals range pattern, it means apply this pattern to this column of the input that's provided here. So here, let's run that and see what happens. So it says that the output, well, there's one variable not shown because I'm using this new data table abbreviated output, truncated output. Let's try it again. So here we see that what we get is we get a new data table, right? Original data table looked like this, right? Where we just had the pause and the subject ID columns. Now we have these three additional columns, chrome, chrome start, and chrome ends. And these come from the definition of our range pattern that we have in this code above that we saw in the previous screencast. We have these named arguments chrome, chrome start, and chrome end in our subpattern list variables that define the different patterns to use. And those are going to be new columns in the resulting data table that's returned. So, so this is sometimes useful when you have a data table with a bunch of columns and you have one of the columns which has like kind of several pieces of information encoded in a character string, and you want to parse them out to several different columns. So here it's not like a super interesting example because here the pause and the subject ID are, I mean, it's kind of a trivial example, but let's go to the man page for capture first df and we can see a more interesting example. So here on the man page in the example section, we have an interesting example using which comes from the SAcct program. So this is a program that was that's used to get information about cluster batch jobs in the SLURM system. And so the output from this program gives us two columns, JobID, which has got a bunch of different pieces of information here, and Elapsed, which has got basically the hours and minutes and seconds that have been elapsed. And so both of these things are character strings which we could parse using regular expressions. So let's try to do that. So I guess the easy thing to do would be to start with the elapsed column. So with elapsed, we have so we can use NC capture capture first df with this sacct df, and then we specify that we want to match the elapsed column with the following regular expression, where we're going to first match the hours with some pattern. Well, so here what I'm going to do is I'm going to use this previous subpattern that we defined in the previous screencast. Here we define this pause pattern thing that's basically matching an integer and converting it to an integer using this type conversion function. So I'm just going to be using that again. Hours equals pause pattern, followed by a colon, followed by minutes equals pause pattern, followed by a colon, followed by seconds equals pause pattern. So if we execute that, what we're going to get is we're going to get this new data table where we have all of the original columns of the input data table, plus the additional columns that were specified using this pattern. And you notice that actually these, so if we save this as, how about sacct match, you know, if we save it like that, then we're going to actually see that that the columns that we have extracted are actually integer columns. So we can do some operations on them, like computing the total, you know, elapsed minutes, like sacct match, you know, elapsed minutes, or, you know, to be, yeah, to be clear, so the number of minutes is defined as the number of hours over 60 plus the minutes column plus the number of seconds times, so over 60 here and times 60 for the number of hours. Yeah. So then we can get a number, a new column here, which is actually, you know, got the total number of minutes. And that's super convenient because the NC function gave us some columns which were already integer numeric values that we can just directly plug into this mathematical expression for calculating the total number of minutes. So after that, we might want to also match the job ID column. And to do that, I mean, all we have to do is we can add another argument here. So we have elapsed as an argument. Here we can match job ID as another argument, right? So to do that, let's see. So to match the job ID, you know, maybe we're going to start out by just matching the job. You know, yeah. So it might be useful to break this down. So instead of doing all of this stuff in one go, let's call this the job ID pattern, which is something that we're going to define later. And let's construct that job ID pattern in a recursive or like kind of a modular fashion. So when we have like something relatively complex to match, like these job ID strings, you know, what I like to do is I like to do this piece by piece, you know, one kind of sub pattern at a time. So here, let's take the sacct df job ID, and let's take a look at those guys, and let's plug them into our capture first vec function. And inside of our capture first vec function, what I'm going to do is I'm going to first match this first thing. So again, this first job ID, it's just an integer, right? So we can use this same pause pattern that we've been matching all along to match that again and convert it to an integer at the same time. And then let's say you know, so in every case, it's followed by a underscore. But after that, there's like a kind of a variable number of things after that. So let's call that after. And let's just match everything else and see what that looks like, and then we'll deal with that later, yeah? So let's call that after dt. And so after dt, what does that thing look like? Well, here we got an error. It says too many functions. Up to one function may follow each named pattern, right? So here, the problem is you didn't give any name here. So let's give a name instead. So let's call this the job. That's the main job ID. And so then after dt, this looks like this. So we first have the job. That's an integer column that we just extracted. And then we have this after thing. So the after thing, well, there's going to be either a integer and then an optional dot batch or extern, or there is going to be a range. So we can match that using alternation, right? So let's try to do that. So here the subject now is after dt after. How are we going to match that? We can match that with nc capture first vec after dt after. And so usually, with regular expressions, when we want to do alternation, we're going to write something like, pattern 1 or pattern 2. And that's something you can totally do in NC as well, except for, instead of using this, the 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 parentheses, which means capturing groups, you should use the non-capturing groups because you're supposed to use the. Well, anyway, so in an NC we don't really ever write the groups. We usually use lists instead. So I mean that's what we can do. We can use a list, and in our list we can say, well, we can either match an integer, pause pattern, same thing that we've been using before, or we can match a well, so it's going to be, so either can match an integer followed by a dot followed by some text, and again here we can call this maybe the task. Here we can call this maybe the suffix. And so here we can just first, let's just see if that matches. That's going to be, whoops, this is just here. Subject 145 did not match, right? So let's use, again, no match, error equals false, just to see what's going on here. So what happens was it matched when we have the task integer ID and the suffix batch and extern, but it didn't match in the other cases. And so so the suffix could be optional because here there's no suffix, right? Or there should be none. So here we can maybe abstract that away into a subpattern called maybe suffix. How about that? Maybe suffix. That's gonna be a list of this guy, but we want to enclose that in, and we want to make that an optional group. And so one way to do, the usual way to do that in NC would be to be optional group like this. You put it inside a list, you put a question mark afterwards. So kind of a shortcut if you want to save typing list twice, what you can do is you can use this helper function called NC quantifier. And so what that is it's going to put all of that stuff in a list, and it's going to put that after it. So the last argument is treated specially, and so this is basically, kind of like how we write the regex code. Basically all of this stuff is going to go into a non-capturing group, and this is going to be the quantifier that's applied to that non-capturing group. So let's see if that works. So indeed, that does work. So now all 5 matches are happening, but we're only getting, so let's recall what the subject looks like again. Actually, even better, instead of using capture first vec here, we can use capture first df after equals list, right? So then we can see the subject at the same time, right? So here we see after is, just 25 here is 25.batch here. We've extracted all that stuff out just fine. In the last one, we've just extracted the start, right? So how does that work? Let's see if we can fix that, right? So here, what happened was in our regular expression, our maybe suffix thing is well, actually we're matching after list equals task pause pattern maybe suffix. So actually we haven't matched this this opening the square brackets in our pattern. So usually when we do this, it's probably a good idea to make sure we're matching the whole to make sure we're matching the whole thing. We can do well before we go on, let's just put this into its own variable so we know what this is. So this is the thing that's supposed to match let's say task dot suffix, yeah. So here, so what we want now is we want to either match the task suffix or we want to match something else, which is going to be this, square bracket. So here we have to escape the square brackets in the regex syntax. And then a start integer, and that's we're gonna use the same integer pattern again, and then an optional end. So here the end is optional again. So here let's call optional ends. That's going to be a list with it's a list sub pattern, and it's going to be well, here we can use NC quantifier again, like we just did NC quantifier. So it's going to be a dash and then maybe an end. And here we can use pause pattern again to get an integer converted, matching an integer and converting into an integer. And here if you use a question mark, that's going to be optional. So let's see if that works. It says task suffix not found because we haven't executed that line of code yet. Let's try it. So indeed, this is working now. So here we have the after thing, which is matching now to, well, the task is always matching here. The suffix is matching for these two guys, which is good. And here the start inside of square brackets is matching the 1 or the 4. And here it's matching the 3 in this case, and we don't have the end in any of the other cases. So here we've got a good match to all of the information in that string. So now the only thing that remains is, well, let's try to abstract this subpattern away. Let's call this, after pattern. After pattern. And so what are we going to do with all of these patterns? So now we know that, well, remember we first matched the job ID with this pattern here. So this whole pattern here, we could maybe call that. Well, so yeah, I mean, actually, so this is like, so let's call this the only job, because this is only matching the job. Yeah. Put this in a list subpattern variable. And here, executing all of this code again. This is still working. But now we have these two patterns, the only job, and then we have the after pattern. So here we can plug that in for our job ID pattern. So here, if we take job ID pattern is going to be list of job, it was only job and after pattern. So this is going to be a subpattern list variable that we're going to plug in here, and we're going to get exactly what we want, I think. So let's check this out. Account match. So here in the match worked, and so we can see we've got all of these additional columns that we specified in that pattern. So now we've got we used NC capture first DF, and we specified that original input data table with just these two job ID and elapsed columns, and then we specified two named arguments to that function. We said elapsed equals this first pattern list, job ID equals this second subpattern list, which we constructed kind of like piece by piece using these different subpattern variables. And the result is we have one function call that gets us extracting everything that we want. We have hours, minutes, seconds from the elapsed column, and we have job, task, suffix, and start and end, which are not shown here, from the job ID column. So yeah, all of that to say that's capture first DF. That's super useful for the case where you have a data table or data frame as an input and you want to parse one or more columns into several different output columns of different using different regular expressions. So it's going to be a different regular expression that you can provide for each one of the different input columns. So last thing I just want to mention is that, you know, NC supports this, type conversion by default. So this thing that's returned by capture first DF, well, we've got a lot of integer columns here because we specified in our subpatterns, we specified this pause pattern a bunch of times. So every time we specified pause pattern, it goes back to this definition that we used in a previous screencast. It says that the pause pattern should be any digits and or commas and followed by this type conversion function, which is going to convert that group to an integer. So the output of the capture first df function is going to give you directly integer columns, which are exactly what you want when you want to do conversions like this with, creating a new column that's actually the total number of minutes, not just the hours, just the minutes, and just the seconds. So thanks for listening. I hope you learned a little bit about how to use regular expressions with your data frames.